Hey, if you're watching this video, you need some extra help factoring quadratics. In particular, we're going to start with when a equals 1. What does that mean? Well, real quick basic lesson. What's a quadratic? It is something in the form of ax squared plus bx plus c. What the heck does that mean? It means that you have some x squareds and then some x's and then you have some number at the end. So that's the basic kind of premise or setup. So when we talk about a equaling 1, that just means we have one x squared and then some x's and some number, which really means that we just will see x squared plus x's plus a number. Cool, there's your math for the day. Let's dive into factoring. Again, if you're watching this video, we've probably already done a bunch of practice in class. This is like the step-by-step. I just need to know how to do it. I don't need to know why or anything. You can learn that from me in class. Here's how to factor quadratics. Let's go. I love using the box method as a visual. It's sometimes called generic rectangles or the area model. You put x squared in one corner. All right, what are we eventually trying to do? We're trying to get x times x. We're trying to factor, right? So we're trying to break it into something times something. Base times height, length times width. So the x squared is going to go in a corner. We'll worry about the outside in a second. All right, the next spot, check, is to go to the easy part, which is the 12. You set the 12 in the other corner. Why? Again, you'll know that if you're in my class, but here's just how to do it. Now we're going to factor all the ways to factor 12, right? Technically, we should be factoring x squared, what's along that diagonal there. But we're just doing 1 times 12, 2 times 6, or 3 times 4. Which combination is going to get me 7 x's? Well, 3 and 4 will give me 7 x's. So I really need 3x and 4x so that I can check off that 7x right there. Cool, I haven't factored yet. Factoring is base times height, length times width. So we have x times x to get that x squared. Now I know that 3 times x will get me that 3x. I can get to 4x using a 4 and then the x up top. And then in the last corner, I have 4 times 3 is 12, so I get that one checked off. So my final answer as a factor is the base, or the length, times the height. Base times height, length times width. Factored that into the two separate x's. Cool. All right, next one. Again, we're just getting more practice here. I picked the numbers to be similar so we can kind of compare some things. So your x squared goes into some corner. Then your 12 goes into the other corner. You multiply that diagonal. That gives you 12x squared. Just focus on the 12. What are the factors of 12? We're factoring x's and x squareds, but right here we're just factoring the numbers. So I've got the x squared. I've got all the ways to get 12. There's a handful of them here, right? But which way gets me the magic 8x? That would be that choice in the middle. If I have 2x and 6x, it doesn't matter where I put them, that will get me to be able to check off that 8x there. All right, now I'm going to go ahead and factor. Factoring x times x gives me the x squared. I can't just go like put 3 and 4 here for the 12 because that's not going to match up with the other information that we have, right? So we got x squared checked off. Now I need 2x. Well, I already have the x up top, so I just need to multiply by 2. When I go to get my 6x, I've already got the x on the side. I just need to multiply by 6. And now the 2 and the 6 multiplies to get that magic 12 at the end. So we've got x plus 6 on one side times x plus 2 on the other side, and we have factored. Alrighty, for our red one, set up the boxes. X squared in a corner. 12 in the other. You multiply the diagonal, that's 12x squared. You write all your lists of factors. There they are. So I've got x squared. I've got 12. How do I get 12x? Ooh, that gives me 13. That gives me 8. That gives me 7. There is no way to get 12x's with this one. This one is a can't factor problem. All right, we move on to the green one. We've got x squared. I'm going to show you that it doesn't matter where you put your x squared, as long as you put your 12 in the opposite corner. You multiply the diagonal, that's 12x squared. You factor 12. Is there a way to get 13? I see it right there. Now really we're trying to get 13x, so I need 1x and 12x, and now I can check off that 13x. We'll go ahead and finish up our factoring here. X squared is x times x I need 1x. I've got the x on the bottom, so I'll put a 1 there. And I need 12x, so I need 12 times the x there. And then 12 times 1 in that last corner works out for me. So now I have my x plus 12 on one side times the x plus 1 on the other side, and I've factored. Alrighty, we got a couple more. If the last three deal with negatives, so if you're not sure about negatives, stick with us on these last few problems. I'm just going to go ahead and set up the boxes right away, and let's go ahead and get our x squareds and then the number. And I'm going to do two problems at once here so we can kind of see that like the same thing's happening no matter what, right? So I got x squared, I got x squared, I got negative 20, I got negative 20. Multiply the diagonal, that gives you negative 20x squared. Multiply the diagonal, that gives you negative 20x squared. So we're factoring the same thing here. How do we get to negative 20? Well, 1 times 20, but it could be where the 1 is negative or the 20 is negative. 2 times 10, but it could be where the 2 is negative or the 10 is negative. 4 times 5, but it could be where the 4 is negative or the 5 is negative. So how do I find a way to get 1x? Well, that combo right there gives me 19, right? I got positive 20 and then minus 1, that's 19. That one gives me negative 19. Those aren't going to work. Negative 2 and 10, that gives me 8. That combo gives me negative 8. Ooh, I see in the last, towards the bottom, there's a way to get a positive 1 if I do 5x and then minus 4x. That will give me the 1x. Sweet. Now I go ahead and factor, get ready to write my answer. X times x is x squared. 5 times x gives me 5x. Negative 4 times x gives me negative 4x. I now have x minus 4 on one side and x plus 5 on the other. Alrighty, we can just go ahead and use all of our factors for this blue problem. So I've got my x squared, I've got my negative 20. Do I see a way to get negative 12? That combo gives me 19. That combo gives me negative 19. 10 and minus 2 is 8. Negative 10 and 2 is negative 8. That combo we already used, that was 1. That combo right there is negative 1. I don't think I see a way to get negative 12. Ooh, wait. What if I put negative 2 in negative 10? Oh, that doesn't work because negative 2 times negative 10 factors to a 20, which is not what we have. So we got to focus on that number up top. This one is another can't factor. All right, let's go and finish it up one more. If you're still hanging with me, appreciate it. We got x squared. We got 14. Doesn't matter what position you put them in. Multiply the diagonal. That is 14x squared. 1 times 14. 2 times 7. Do I see a way to get negative 9? Wait, could I do the negative 2 and negative 7 to get negative 9 here? Actually, I can in this because negative 2 times negative 7 gets me 14, which is the number that I'm factoring. So I can use the double negatives here. I can use negative 2 and negative 7 to get negative 9x. I've already got the x squared, I've already got the 14, and I kind of double checked my work there. Let's wrap it up. X squared is x times x. How do I get to negative 7x? I just put negative 7 to go along with that x that's already there. How do I get negative 2x? Put a negative 2 to go with the x that's already there, and then negative 2 times negative 7 gets me that positive 14. I can double check that math with the double negatives there and write my final answer as x minus 7 times x minus 2. Whoo! There we go, a bunch of factoring.